الكارثة والمصيبة الكبيرة الحاصلة في السودان دي. يعني نتمنى من الله سبحانه وتعالى إنه يرفع البلاء ويخفف الضرر. وتضامنا مع المسألة الكارثة الكبيرة دي، إحنا حننزل عدد من اللينكس لأي شخص بيحب يتبرع للكارثة دي. ما بنحدد منظمة معينة، في عدد من المنظمات الطوعية، وحننزل بها 5 6 7 منظمات، واللينكس كلها موجودة في الشات. وبنطلب من كل المستمعين، كل واحد لو أخذ له دقيقة دقيقتين سريع جدا بس، اختار المنظمة اللي بتنفع معك وبتتوافق مع مبادئك، ولا اللي بتعرف عنها أي معلومات ولا كده. ما مهمات واحدة، اختار الواحدة اللي بتناسب معاكم، وخذوا لكم دقيقتين ثلاثة اتبرعوا. وحندي الناس فرصة 3 4 5 دقائق تتم الحكاية دي. بعد ذاك ممكن نبتدي الندوة. فأي زول أونلاين you can go ahead وأمشوا للشات، خشوا على اللينك بتاعت الشات وحتظهر لكم عدد من اللينكس. ممكن تبتدوا تعملوا تبرعات. أثناء ما الناس بتعمل الحكاية دي، بس كنت داير أذكركم إنه زي ما قلت دي ندوات أسبوعية، وإن شاء الله دايرين من الناس برضه تخلي بالها للجروب بتاعتنا والفيسبوك وكده، للندوات بتاعت الأسبوع الجاي. في عندنا عدد من الخيارات، لسه ما حددنا واحد، لكن إن شاء الله كلها موجودة في الجروب بتاعتنا. وفي اليومين الثلاثة الجايين ديل حننزلها كلها. again للناس اللي دخلوا حسي متأخرين، يا ريت تخشوا في اللينكس بتاعت الشات واختاروا المنظمة اللي بتتوافق معاكم، عشان الناس تعمل تبرعات لأهلنا والناس المتضررين بالفيضانات. يعني حالهم يغني عن الذكر. يعني مصيبة كبيرة وكارثة ما حصلت لي أكثر من يمكن 100 سنة ولا كده، والناس بتموت وعيانة ومرضانة وما عندها حتة ناشفة حتى تقعد فيها ولا ترقد فيها. ف يعني بنذكر الناس ونتضرع ونطلب من الله سبحانه وتعالى إنه يرفع البلاء ويخفف الضرر. وزي ما قلت هناخد لنا بس دقيقتين ثلاثة ننتظر باقي الناس، أي واحد يحب يتبرع عشان يتم الحكاية دي قبل ما إن شاء الله نبتدي الندوة في ظرف ثاني دقيقة أو دقيقتين. في الأثناء دي أكلمكم بس سريع على الندوة دي مع بروفيسور الفاتح الطاهر. طبعا بروفيسور من MIT. أنا ما داير أتكلم عنه كثير، حخلي دكتور علي الحسن هو اللي حيقدمه وحيديكم نبذة عنه. لكن داير أذكر لكم سريعا دكتور علي الحسن اللي هو اللي حيدير الندوة. هو دكتور مهندس PhD في الهندسة، وهو مدير إدارة تخطيط إمدادات المياه في التوين سيتيز، والزول المسؤول من إمداد المياه في مدينة مينيابوليس وسان بول، اللي هو البوبيوليشن بتاعه أكثر من 3 مليون نسمة. وهو يعني في المنصب دي من سنة 2012، أكثر من 8 سنين إلى الآن. وأنا عايش في التوين سيتيز، والحمد لله ما حصل يوم واحد قطعت المويه عندنا، ولا سمعت إنه حصل قطعت مويه ولا حاجة قريبة من كده. ف زي ما قلت هو مدير إدارة تخطيط إمدادات المياه في التوين سيتيز من 2012، والإدارة دي مسؤولة عن توفير المياه لأكثر من 3 مليون نسمة. والدكتور علي قبل ما يشتغل وياخذ الوظيفة دي يشتغل برضه في القطاع الخاص في البرايفت سيكتور، مهندس استشاري، يشتغل في كاليفورنيا، ويشتغل في مكتب الولاية الهندسية في كاليفورنيا لإدارة المياه في نيو مكسيكو برضه. ودكتور علي PhD الدكتوراه بتاعته في الهندسة في الووتر ريسورسز مانجمنت. يعني تخلي من أكثر الناس الوحيدين في العالم إنه يدير ندوة زي دي. والدكتوراه بتاعته من جامعة طوكيو في اليابان. again قبال ما ندي دكتور علي الفرصة، تذكير أخير لأي زول ما دخل في اللينكس، خشوا في الشات واختار اللينك اللي بتنفع معاكم، ويا ريت تتبرعوا بالحاجة اللي بتشوفوها مناسبة، المبلغ اللي بتشوفه مناسب، المنظمة أو الجهة اللي بتشوفها مناسبة. عدد كثير يمكن 6 أو 7 منظمات اللينكس بتاعتهم موجودة. وبكده ممكن أنا أدي الفرصة للدكتور علي، تفضل عشان تدينا كمان فكرة بسيطة عن البروف وعن المحاضرة وكده. تفضل يا دكتور علي.
شكرا جزيلا خالد. السلام عليكم ورحمة الله تعالى وبركاته. بسم الله الرحمن الرحيم، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. حقيقة برحب بكل المشاركين في الندوة، وأشكر الجالية على إتاحة هذه الفرصة للحديث عن هذا الموضوع في هذه الفترة المهمة وهذه المعضلة التي يمر بها بلدنا الحبيب السودان في الفيضانات. حقيقة نسأل الله عز وجل في البداية أن يرفع عن أهلنا في السودان البلاء وأن يسهل عليهم أمورهم ويدفع عنهم محنة الفيضانات. كما نسأل الله أن يسهل على أبنائنا الممتحنين للشهادة في هذه الأيام. يعني حقيقة ظروف صعبة جدا إنه أبنائنا في السودان يمرون بالظروف الصعبة بتاعت الفيضانات والكورونا فيروس وكله، وبعد ذلك إن شاء يعني حيجلسوا اليوم لامتحانات الشهادة. نسأل الله سبحانه وتعالى أن يعينهم ويعين أهلهم على هذه الظروف الصعبة، ونشكركم كلكم، ونسأل الله سبحانه وتعالى أن يقبل منكم ويجزيكم خير الجزاء على مساعداتكم. زي ما ذكرنا الأخ خالد بأنه في مجموعة من المنظمات عاملة لدعم ومساعدة الأهل في السودان. موضوع اليوم كما هو موضوع الساعة الآن في السودان، موضوع يقدمه لنا بروفيسور الفاتح الطاهر، فيضانات النيل الماضي الحاضر والمستقبل. Nile Floods past, present and future. نبذة بسيطة عن بروف الفاتح، ونحن يعني شاكرين له في الجالية السودانية هنا في مينيسوتا لأخذ الزمن لمشاركتنا بعلمه الغزير الوافر. بروف الفاتح is a professor of hydrology and climate and professor of civil engineering and environmental engineering at the Massachusetts Institute of Technology, MIT. الدكتور الفاتح earned his Bachelor of Science in Civil Engineering من جامعة الخرطوم، وحاصل على ماجستير في الساينس في الهيدرولوجي من National University of Ireland. كما إنه حاصل على ماجستير في Meteorology and a Doctor of Science in Hydroclimatology, both from MIT. Prof. Al-Fatih is a recipient of the United States Presidential Early Career Award for Scientists and Engineers in 1997 and the Kuwait Prize in Applied Science in 2000 for the work on climate change. He has been elected Fellow of the American Geophysical Union in 2008, and he received the Hydrologic Sciences Award of the American Geophysical Union in 2017. Dr. Fatih in 2019 actually published his first book with the title A Path Forward for Sharing the Nile Water Sustainable, Smart, Equitable, and Incremental. So I think this is the best person to talk to us about the what's happening with the flooding and also with the Nile water in Sudan. The topic today, as I mentioned, Prof. Al-Fatih, he will describe the history of the Nile floods since the time of the pharaohs, the recent observed variability of the Nile floods, as well as projections of how climate change may impact the frequency of the Nile floods in the future. He will also discuss the mechanism of the climate system that may explain variability in the Nile floods, including explanations of the ongoing flooding in Sudan. بهذا أقدم لكم بروفيسور الفاتح، ونحن شاكرين لك جزيل الشكر يا بروف على أخذك الزمن لمشاركتك لنا بعلمك الغزير. كتر خيرك.
Okay, thank you very much, Dr. Ali. Thank you very much to الجالية السودانية في مينيسوتا. I appreciate their invitation. I have here in the first slide a satellite picture of the Nile River, and you could see here from the Nile Delta and going upward, the area of Abu Hamad, and then until you get to Khartoum. The picture also showed all these clouds in the Ethiopian highlands, and so I thought it's very representative of what I would be talking about.
And I would like. ممكن تعمل share لأنه it's not showing.
انا شايفها يا علي، لكن افتكر الناس بس تضغط عليها في البوتوم رايت كورنر
اوكي
عشان الصوره تظهر لهم.
I don't know if everyone's seeing it now. Can we get indication? Can I get indication يا علي if people are
جت أكيد يا برو.
Yes, okay.
جت أكيد للناس اللي شايفينها.
Yeah, so this is the first slide, which shows, you know, the Nile Basin and, you know, the setting that we're going to talk about. And I would like to start by showing pictures that were discovered in caves in the middle of the Sahara Desert. Pictures that shows, I mean, sometimes described as African rock art, describes animals like elephants, cows, and giraffe that have been found in caves that in areas that you usually don't see these animals today. And so that's indication of what kind of past climates you have in those parts of the world. And here is a more extensive data set. Each of these points is like a master or a PhD by a student who basically spent time collecting samples on things like soils, charcoal, human bones, pottery, large animals, fish, plant remains in different parts of the Sahara Desert. And by doing radiocarbon dating, you could find out what those remains, what periods belongs to. And with some more analysis, this picture was drawn for the history of the Sahara Desert for the last 10,000 years. So in the vertical here, you see the north-south direction from central Sudan to like the Mediterranean. And you see on the other direction is time before present. So this goes up to like 10,000 years ago. So 10,000 years ago, the Sahara Desert was extensive, just like as it is today. And then about sometime between 10,000 and 9,000, significant greening took place. And that continued for about 3,000 years. And then you start this trend in drying that started in the north and then just progressed to the south. And you see that's basically brings us to the current climate that we live in. So this is a very significant paper that was published in Science, basically reconstructing the history of life and climate for the Sahara Desert during the last 10,000 years. And those changes that are described in this picture are caused by or triggered by changes in the orbital parameters of the sun. For short time scales like years and decades, we could assume the parameters on how the Earth rotates around the sun to be constant. When you talk about time scales of thousands of years, those parameters are no longer constant. And I could talk more about this if people are interested later. However, going back to the story of climate, you see like 10,000 years ago, people were clustered on the Nile Valley and very few people were there. And then they spread out as the climate gets wetter. You see evidence here, all these red dots are basically a habitat for humans. And then more recently, more like 6,000-7,000 years ago, you get again the expansion of the desert and the clustering of people back around the Nile. So the climate and life of this part of the world are linked very strongly. And that 6,000 years climate change resulted in or triggered the well-known pharaonic civilization. This is here, Akhenaten and his family, Nefertiti and their children, Tutankhamun and others. And there are a long story that could be told about this picture. Akhenaten, of course, is a very significant pharaoh. He was revolutionary in terms of changing the religion from Ammon to Aten, and in terms of also architecture and also moving his capital and so on. There is a long history that goes with Akhenaten, and he is also known as Amenhotep the Fourth. There are theories that say that the mother of Akhenaten is actually a woman with the name Tai, and that Tai is of a Nubian origin. So it has connection to Sudan, and she was known to be an influential and wise woman. And she is the mother of Akhenaten, the most significant, maybe the most significant of the pharaohs. So the southward shift of the desert margin that caused by the climate variability helped trigger the emergence of the pharaonic civilization and migration into the desert and away from the desert was the dominant mode of adaptation to climate change thousands of years ago. The history of the Nile and the floods of the Nile has been also mentioned by this gentleman with the name of Pliny the Elder, very well-known natural historian, naturalist of Roman origin. He is the one who wrote the first encyclopedia of natural history. And when he visited Egypt, he found the Egyptians in that time gauging the level of water, the floods of the Nile, using a device or a construct what's called a nilometer. So the same way you measure temperature with a thermometer, you measure the Nile with a nilometer. However, Pliny the Elder described how life in Egypt was, ranging from hunger to disaster, depending on the level of water in the Nile. So too little water results in hunger. Too much water results in disaster. And that's in many ways the story of hydrology as a science. It deals with droughts and floods. Too much water is disastrous, and too little water could cause hunger. And people like to be somewhere here in the middle, security and abundance. And so when we talk today about flooding, we are really talking about this end. However, we have to remember that our objective is not to bring this down all the way, but to really oscillate somewhere around abundance and security. And we are going to come back to this later. This is one of my favorite drawings by David Roberts, who visited Cairo more recently in about 1850. And this is a picture of a nilometer, and that's how the Nile floods were measured. You see here, this is a construct next to the Nile, and this column here is graded. So these gentlemen, they come down every day and they basically record which level is the water. And that's the earliest device for measuring any geophysical phenomena. And it resulted in this longest human record of any geophysical phenomena, which is the Nile level fluctuations. The floods of the Nile is maybe the most monitored compared to any other phenomenon going back. These are not like paleoclimatic records that are in tree rings or in geological records. These are human recorded measurements, and they go for since 641 AD. And recently, one of my students, Kasha Nickel, put this record in comparison to the recent record. So the Nile had a very good record starting in the 19th century. But when you put it in the context of this nilometer record, it's really a very short period of time. And it shows how the fluctuations of the Nile floods have been through history, sometimes with very significant droughts and sometimes with very significant floods. Okay, and our recent history is just this short period that we have here. So before we get more into the hydrology of the Nile and the floods of the Nile, I would like to share with you some background for basic understanding of the Nile hydrology. The unit I'm going to use is a unit that's huge. It's 12 cubic kilometers. Think of a cubic kilometer. It's a kilometer by a kilometer by a kilometer. So that's a huge volume of water. So if you think of 12 units of that size, 12 cubic kilometers, and you call that one unit, then the hydrology where the water of the Nile comes from, 2 of those units come from Uganda into South Sudan. 1 of the 2 units gets lost through evaporation in the swamps. The Sobat River travels from Ethiopia and supplies 1 unit. So that's what makes the White Nile. 1 unit from South Sudan, 1 unit from Sobat, that makes it 2 units of the White Nile. And here in Khartoum comes the mighty Blue Nile with 4 units, larger than any other river in this system. So 4 from the Blue Nile and 2 from the White Nile, they join in Khartoum and they make 6 units. And those 6 units basically join with another 1 unit coming from the Adbra River to make 7 units traveling into Egypt. So roughly how much water gets into Egypt is about 7 units, and that's the equivalent of 84 cubic kilometers. 6 out of those 7 units, they come from, 6 out of those 7 units, as you see here, 6 out of the 7 units, they come from Ethiopia. I have to say also that 6 out of the 7 units are consumed in Egypt, and Sudan did not consume its share of the Nile water up to now. It consumed about 12 cubic kilometers or so. So that gives you a general rough idea when people talk about the Nile, where does the water come from and where does the water go? And so when we talk about flooding today, a lot of our focus would be on the Blue Nile, because that's really what had been the source of the flooding that happened in Sudan recently. So another background chart about the Nile, you see here, this is the contributions of water in the White Nile, the Blue Nile, and the Adbra River. And you see how the White Nile, really the base flow of the river, the Blue Nile brings the majority of the water, and the Adbra River adds. It's supposed to peak like, the first week of September or so, around that time, it moves around. But this is really peaking down in Ethiopia, in Egypt. In Sudan, it is supposed to peak earlier. And that time, the last 1 or 2 weeks of August, that's an important time frame to think about, because I'm going to come back to it later. So that's one element I would like you to return from this figure. Another is that at maximum, you're talking about 700 million cubic meters per day. And to have that calibration is important, because we are going to talk about how much water came up. You see everyday reports about how much water the Blue Nile is bringing. And so on average, we expect about 700 million to come from the whole Nile, not only the Blue Nile. Also, another important element to understand about the Nile is this rich spectrum of variability from year to year. There is a very significant variability that takes place in the Nile floods. And that had been going on for ages, for a long time. We call that interannual variability. And so when we think of occurrence of a flood, like flooding that happened in Khartoum, we have to think part of it has to do with this seasonality. That's why we expect most of the flooding to happen at this time of the year. But that has to coincide in a year in which the flow itself is significantly above average. And that's what causes floods when they happen in Khartoum and other sections of the Nile. Of course, the history of the Nile floods had been mentioned in the Bible and the Quran. All of us have heard about the 7 years of plenty followed by the 7 years of shortages as part of the verses of the Quran. And that what in hydrology, where we interpret that, that's really tell us that these fluctuations in the Nile floods have been of interest to people in the Nile Valley for thousands of years, even being documented in these holy books. And so there is speculation that the Pharaoh of Egypt that was at the time of Joseph was this guy, Amenhotep III, but that's really remains to be speculation. And it's a connection between what's in religion and what's in the books to what really could have happened in reality during the times of the pharaohs. I mean, Amenhotep was known to be a king during times of unprecedented prosperity, cultural and international power, and he is the father of Akhenaten that I described earlier. So the question that I would like to focus on today is what causes this year-to-year fluctuations of the Nile? How can we explain this natural variability in the flow? And so this variability that we see it here in these very rich fluctuations, in some years it's about 40 cubic kilometers, and in some years the Nile brings about 130 cubic kilometers. That's a very wide range. So what causes these changes from one year to another? In a paper that we published in 1996, we proposed a theory for how that mechanism for that variability by relating the annual flow in the Nile to a sea surface temperature in the Pacific Ocean, a phenomenon called El Niño Southern Oscillation. It has to do with the temperature of the tropical Pacific Ocean. And you see that correlation is such that when the temperature in the Pacific Ocean is warm, you tend to have low flow in the Nile. And when the temperature of the Pacific Ocean is cold, relatively cold, you tend to have floods in the Nile. So that's something to remember too. So there is a correlation between the sea surface temperature in the Pacific Ocean and the Nile floods. And the correlation explains 25% of the interannual variability in the flow of the Nile. So that's the significant correlation. And it happens such that when we have warm SST in the Pacific Ocean, we call that phenomena El Niño. That's this word here. When we have that El Niño condition, we tend to get droughts in the Nile. When we have cold SST, which is the opposite with La Nina, in that case, we get flooding in the Nile. We get very high flow in the Nile. El Niño means in Spanish, it means the baby child, the boy baby child. And La Nina is the female version of the word. And that's the case because this phenomena of warming and cooling used to happen off the coast of Peru, where the fishermen, they would go to the sea and they would observe it happening at the time of Christmas. And so that's how they related this El Niño as the name, I mean, the birth of the child of Christ to that phenomena. And so the name here, El Niño and La Nina. El Niño is associated with droughts. La Nina is associated with floods. So that's the work that we did in 1996 and we built on it. Let me give you a little bit of background about, just a second here. I need to change the sound so that you could hear the video with me. So this is a video that gives you some idea about the El Niño phenomenon.
Every few years, the El Niño phenomenon kicks into life in the Pacific Ocean around the equator. It can affect weather around the world, changing the odds of floods, drought, heat waves, and cold seasons for different regions, even raising global temperatures. But what is El Niño and how does it happen? Firstly, we need to know what's normally happening in the tropical Pacific. This vast stretch of ocean sees consistent winds, called trade winds, that blow from east to west. These winds push warm water near the surface in their direction of travel, so the warm water piles up on the western side of the ocean around Asia and Australasia. On the other side of the ocean, around South and Central America, as the warmer water gets pushed away from the coast, it's replaced by cold water which is pulled up from deeper down in the ocean, a process called upwelling. This creates a temperature difference across the tropical Pacific, with warmer water piled up in the west and cooler water in the east. Warmer water adds extra heat to the air, which causes the air to rise with more vigor, and it's this rising air that creates an area of more unsettled weather, with more cloud and rainfall. That rising air in the west sets up atmospheric circulation across this part of the world, with warm, moist air rising on one side of the ocean and cooler, drier air descending on the other. This circulation reinforces the easterly winds, so this part of the world sits in a self-perpetuating state until El Niño begins. If conditions are right, tropical Pacific weather systems, or slow changes in the ocean around the equator, can set off a chain of events which weaken or even reverse the usual trade winds. With weakened trade winds, there's less push of warm surface water to the western side of the ocean and less upwelling of cold water on the eastern side. This allows the usually colder parts of the ocean to warm, cancelling out the normal temperature difference. Because the area of warmest water moves, so does the associated wet and unsettled weather. This changes rainfall patterns over the equatorial Pacific, as well as the large-scale wind patterns. It's this change in winds which has a knock-on effect, changing temperature and rainfall in locations around the world. The main impacts are around the tropics, where you see an increase in the risk of floods in Peru and droughts in Indonesia, India, and parts of Brazil. But virtually wherever you are in the world, El Niño has the potential to affect you directly via the weather or indirectly via socio-economic impacts. There's another impact from El Niño which happens because of all the extra heat at the surface of the tropical Pacific. This releases vast amounts of energy into the atmosphere, which can temporarily push up global temperatures. This is why El Niño years often feature among the warmest on record. Each El Niño event is different, so the global impacts can change. You can find out more about the differing impacts of El Niño on our website.
So this is basically the background about the El Niño and the opposite of it, which is the La Niña phenomena. So the Pacific sea surface temperature, the SST of the Pacific Ocean, which causes El Niño and La Niña. El Niño is one side of the coin, La Niña is the other side, is a major factor in shaping climate variability and change over the Nile Basin in the past and in the future, as I showed earlier. One thing about this SST is also that it's quite predictable. And so when you have, if basically the models are available now and people are using them to make predictions, and this is one example where in April, models predicted what the future is going to be in like 6 months, and they were successfully doing that. The value of those predictions is that we could easily translate them into predictions about the flow in the Nile, being low, average, or high, depending on the conditions in the ocean being cold, normal, or warm. And this theory actually for a while was being used to make operational forecasts by the Eastern Nile Technical Regional Office. And basically it tells you that if you have a prediction of SST being cold, you could almost rule out the possibility of having a low flow. You could say it's either average or high, or the opposite, if the temperature is going to be warm, you could almost rule out the possibility of a high flood. And so that provides a very good opportunity for prediction. One of my students, Mudassir Zaroug, a few years ago, published a paper in which he showed in a dam station in Sudan, the average conditions during El Niño years and the average conditions during La Niña years. And you could see here that there is a big difference between the two. So when you have El Niño, then the expectation is that the peak of the flood would be significantly smaller than the peak of the flood during La Niña. So the other thing that he also explored is something very interesting. He noticed that when you have an El Niño event followed immediately by La Niña, like what happened in 1988, there is a likelihood of having extreme flooding during that year. That's what happened in 1988. And that was actually repeated in 98, in 2007, and 2010. So the recipe for having record-breaking floods, like what had been happening recently in the Nile, is an occurrence of a warming in the Pacific Ocean followed by cooling. So with that background, let's look at what happened this year. So what is the present condition in the Pacific Ocean? Up to May of this year, the conditions were such that the SST basically was very warm in the Pacific Ocean. And then suddenly around May, there have been a change into a cold SST. So that fits the pattern that I was describing. And you see here now, up to like a few days ago, the temperature in the Pacific Ocean is significantly cold. So that's really set the stage for having flooding in the Nile. The fact that the Pacific Ocean is relatively cold now and have been cold for the last few months over a large area. So we have a La Niña event in development in the Pacific Ocean, and that's partial explanation for why we are getting flooding in the Nile. You see here the SST, this warming followed by cooling that I have been talking about. when that happens around the rainy season in the Nile, that's when we get the recipe for big floods. And that's what happened this year. We had the temperature really warm, and then in May, we had a sudden cooling that basically set the stage for the La Nina conditions. So that's the role of the Pacific Ocean. Another student of mine, Muhammad Siam, in 2015, he studied the role of the Indian Ocean by looking at the Nile flow in Dongola. So he took a 1 century of river flow between 900 and 2000. And so this is the river flow in Dongola, the seasonality of it. And he looked to correlate the Pacific Ocean to this flood. And that's what he obtained here. So like 25 to 30% of the variability explained. That's what I showed earlier. But what's interesting is also he found a region in the South Indian Ocean, this region here in the South Indian Ocean, where there is a similar correlation to the Nile flood. Similarly, when the temperature is cold in this region, the likelihood that you will get to have floods. And these two factors are independent of each other. So now we have indications that both oceans, the Pacific and the Indian Oceans, they play a role in shaping what kind of flooding conditions you have in the Nile. When I went to the NOAA website, their most recent picture of how the global oceans look like, this is the global picture of the oceans. And what's one thing that struck me when I saw this is you see the pattern of cooling in the Pacific Ocean. The Pacific Ocean is now colder than average, because this is the difference from the average, is colder, while the South Indian Ocean is also colder. So from both oceans, the conditions are ripe for having large floods on the Nile. The work of Siam here shows that if you think of conditions when the South Indian Ocean is cold, and the ENSO, which is the Pacific Ocean, is cold, the probability in the past of having floods on the Nile is 83%. So it's almost a certain probability that when you have this kind of pattern of cold SST in the Pacific Ocean and cold SST in the South Indian Ocean, the Pacific, the tropical Pacific, and the Southern Indian Ocean, there is almost certainty that you're going to have large floods on the Nile. Occurrence of this pattern is not something that happens every year. So sometimes you may get cooling in the Pacific Ocean, but the Indian Ocean is just normal, or vice versa. So having both of them occurring at the same time raises the probability to a significant degree of having big floods on the Nile. So that's what did set the stage for having the flooding that we experienced in Sudan recently, is the conditions in the two oceans, the Pacific and the Indian Oceans, were such that the atmospheric circulation and the rainfall patterns in the tropics are consistent with having floods on the Nile. So let's look at that even more closer. But before I go into that, when we talk about flooding, there are usually two types of flooding. So people have to differentiate. Flash floods that result from local rainfall. And then there are floods that really associated with the low flow that's coming in the Nile, and that's associated with the rainfall over Ethiopia. So the local rainfall or the rainfall over Ethiopia, these are the two connections that we have to the flooding that happens in Sudan. So let's look more carefully at those. And to look at those, what I did actually in preparation of this seminar is I looked at the satellites, the NASA satellites. That there is a product called the multi-satellite precipitation estimate, basically a merger of information from more than one satellite that tells you the precipitation patterns around the world. And I would also like to orient you to the geography. When we talk about flooding in the Blue Nile, we are talking about this small area that we call the Upper Blue Nile, this area that I'm pointing to here. North of that, we have the basin for the Abra River. And south of that, we have the basin for the Sobat River. So in the focus that I would like to emphasize now, I would like to talk about this Upper Blue Nile, assumed to be falling between these latitudes and longitudes. So we are looking at a square around this area. And so the first outcome of this analysis is that if you look at June, July, August, September, the average from all the satellite data from 2000 to 2019, you see here the maxima of the rainfall over Ethiopia that showed up here. And that's really why the Nile exists, is because this peak of rainfall over Ethiopia, that's what caused the Nile to exist in the first place. But we compare that to what happened in this year, and you see immediately that the amount of rainfall that had been experienced this year is significantly larger than what had been in the last 20 years. So that's another more direct evidence that this rainfall over Ethiopia that relates to the conditions in the global oceans, that rainfall is what really caused the flooding that had been observed in the Blue Nile. So we could also look at, these are satellite maps of precipitation over Sudan and Ethiopia during the period from July, August, and into September. So these are daily maps. And you see how, complex is this rainfall phenomena and how it varies from day to day, covering different parts of the country. And however, I would like you to focus your attention to this area here. This is the area that we really would like. That's where the sources of the Blue Nile are, is where I am pointing here. And you could see that, early on in July, there was a lot of rainfall, but now in August, very little rainfall was occurring. And however, later on in August, the last week of August, now it's going to start around 22nd, 23rd, this area received a lot of persistent rainfall. You see here, this blue, around this corner actually persisted until September. So in general, the pattern that we see from those maps is that in July, you had a lot of rainfall. It subsided a little bit in August, and then there was a peak towards the end of August. And so if we look again at this, what happened in the second part of August, we see here, this is the region that I'm trying to draw your attention to, persistent period of like this blue around this corner, and that's the source of the Blue Nile. And that's what, to a large degree, caused the flooding that happened, that rainfall that happened towards the end of August. You see it here, the period between mid-August to until like 2 days ago, and this rainfall that happened over the Blue Nile catchment is what resulted in the flooding that happened. You see it here compared to the long-term average of the seasonality of the rainfall over this region. So we see in July we were having wet conditions, above normal, and then there was a relatively drier than average period in early August. But this rainfall that happened toward the end of August, significant amount above the average rainfall, but also happening at a very critical time. Remember what something I said earlier, which is this time toward the end of August, this is the time of the peak of the Nile flood. So an important aspect that caused this flooding is that this excessive rainfall that I'm pointing to here, happened basically at the most sensitive time, which is the time of the peak of the flood. So with that, that kind of situation did happen to some degree in the past. It happened this is in 2007. We also had more rainfall than less rainfall than we had rainfall later on. 2007 was a big flood year, but if you notice here, the magnitude of the anomaly was not as high. 2010 was another flooding year. Similar pattern also, flooding happened towards the end of August, above average rainfall towards the end of August in Ethiopia, and that's associated with floods. Last year, on the other hand, you see the rainfall was at average or below average in most of the season. So in conclusion, as we think that this event here that happened around the 23rd to toward the end of August, of having rainfall over the upper reaches of the Blue Nile that exceeded the expectation, the high expectation. The rainfall on average is high, but this was extremely high and happening at exactly the time of the peak of the rainfall. Those are the factors that together explain extreme flooding that happened in Sudan. You see it here between 8:15 and 8:31. That's the climatology. That's what we would expect every year, and see what happened in 2020. A very significant, flooding in this corner here, and we think that's what's responsible to that. But like with every natural disaster, it's a convolution of hazard and vulnerability. And the risk of any natural disaster comes from hazard and vulnerability. Hazard is what comes from nature, and that's what I have been discussing. Vulnerability is what really is caused by society and human activity and what people do and how people prepare for those disasters. And so a lesson that we learned from recent history in Sudan related to the Nile, going back to the record that I showed you earlier, this is a remarkable record. If you look at the El Nino year in this record, all these low flow years, all these drought years in Sudan, all these drought years were El Nino years, all of them. And you see in all of this year, the flow of the Nile was very low. However, only one of those years, 1888, had been recorded in the memory of the nation. 1888, for those of you who don't know, it corresponds to 1306 in Hijri. And that's the famine of the, this is Maja'a Sana Sitta in Sudanese history. This 1888 was an El Nino year, and Maja'a Sana Sitta was caused by an El Nino year. And it had a large impact in Sudan, many stories that you may have heard in oral history. So although when you look at this record, 1888 is really not the most extreme year, The most extreme year is actually 1914, where the flow of the Nile was only 40 cubic kilometers. It's like significantly less than it. However, that year was not really significantly remembered. It did not leave a similar impact on people like the year 6. So the question is why? And that has to do with the socioeconomic situation in Sudan. So during the 1880s and 1888 in particular, the Khalifa Abdullah, who was the ruler, who was busy with wars, and he had his army moving into Ethiopia and all of that, the country was not in good shape. In 1914, in contrast, we had a much more stable conditions, unfortunately under occupation at that point, under colonization. But what this is really highlights is that what you get at the end, the risk of hazards, natural disasters, could really are not a result only of what nature offers at you, not nature throws at you, but also how prepared and how vulnerable is the society. With that lesson, let's look at what's happening in Sudan. In Sudan recently, the most significant thing that happened in the last 60 or 70 years is this very large increase in population. Here documented according to the UN records based on the population for Khartoum, which is now about 6 million. Some people would question that and they say it's more like 10 millions, but it did rise very high. And that was associated with expansion of the population. You see here, this is based on satellite, maps. You see how Khartoum did evolve from 1984 very significantly, especially if you look at the peripheries of Khartoum. Let's repeat this movie. Let's look at this area here, the area of As-Salha and so on, west of the White Nile. And you could see it didn't exist in early in the 80s. And then suddenly the whole area appears. You see this whole expansion. And all this area was west of Umdurman and east of Bahri are now occupied by large populations of people who moved from the different regions. And they basically had to settle in those areas. And that settlement happened without much really planning that takes into account areas and conditions of flooding. And let me give you a concrete example for that. One of the areas that gets a lot of flooding is the area of what we call Sharq al-Nil, or east of the Nile. You have all these wadis that basically contribute water. Let's focus on this area here, in an area called the Tamaniyat. It falls between these two wadis. A lot of flooding ensued that happens when you have rainfall. And that this time, actually, this whole village of Tamaniyat was totally wiped out. The whole village was totally wiped out due to this flooding. And that's something that's quite preventable if there were flooding zones that are already determined, and if villages located in places like this could be moved to other places. But this kind of vulnerability is not only for the poor neighborhoods in the peripheries of the city, but also this is Sharq al-Nil in Sudan, which all of you know about. And there have been a lot of development happening here without really respect for nature. You see here Sharq al-Nil in front of Al-Qasr al-Jamhuri. This area actually experienced a lot of flooding with these floods. And you see Shar'a al-Nil here, when it came actually in front of Al-Ghasr al-Jamhuri, instead of like, they did even push it more. It really was built on the Juruf, where the floodplain, and basically reduced the cross-section where the Nile could really flow. And you see here that it's very short distance between the street, and that's even more severe when you look here in front of Burj al-Fatih. You see how the the street is actually just right next to the river, and that's so those kind of developments left Khartoum much vulnerable. On the positive side, some of what society did actually had been positive, like building of a Damazin. One of the success stories related to this flooding that happened in Sudan is the fact that the Ministry of Irrigation was able to use a Damazin and Roseris dam and the reservoir as a flood protection. So the flood actually at some point coming into Sudan was about 900 million cubic meters per day. That's a very high flow, okay? And successfully, the engineers were able to like store some of that water and release only about 600 millions. And even with those 600 millions, significant flooding happened in Khartoum. So without the use of a Roseris as a storage facility, as a way to really manage floods and prevent flooding, it would have been much worse than what had happened in this flooding season. So now looking into the future, one of the things that relates to the very soon future is GERD, the Great Ethiopian Renaissance Dam. GERD actually is going to have very positive impacts on flooding. This is here now an estimate of like the natural seasonality of the flow in the Blue Nile, and this is what would happen after GERD. So you see here that GERD is going to really reduce the peak of the flood significantly, while increasing the flow during the dry season. And so likely that if we don't get a big flood in the next year or two, if GERD is completed and operated, that this flood that we have now may be the last significant flood that the reaches of the Nile between Ethiopia and Egypt would experience. Of course, there are going to be flooding associated with Hadbara River, maybe flooding associated with the White Nile, but the Blue Nile is going to be controlled by this structure to a large degree. A lesson that, in order to believe me that's going to happen, I did dig the data for the highest one dam. Before building the highest one dam, there were huge fluctuations in the flooding of the Nile that used to be experienced in Egypt. And then the dam they started filling it around 1970 or slightly before that, and you could see how these wild fluctuations now are quite muted. So after the construction of GERD, something like this is going to happen, and you could see how the big difference in terms of flooding that would result. You have to realize that GERD is not as large as the highest one dam, but it's enough to really be able to tame the seasonality. The highest one dam is large enough that it really controls not the seasonality, but also the interannual variability. But after starting to fill the dam, you could see here it took a few years. So it doesn't happen just suddenly. It's just like not next year we are going to wake up and there are no floods, but maybe in 2-3 years that kind of pattern would develop. So that's actually is welcome news in the near future. Another process that's going to happen in the future to the Nile floods is the process of climate change, just like the rest of the world. And there are indications that with climate change, those El Nino and La Nina events that I talked about earlier, they are going to be more extreme and more frequent. So that's, in a way, is actually not good news. So in general, with climate change, towards the end of the 21st century, we are likely to see conditions in the oceans that are more conducive to flooding, more variability. And in a paper that we published 3 years ago, we projected then that changes in the frequency of El Nino and La Nina we're going to really change the distribution of Nile floods towards more flooding events, towards more large flooding events, as shown in this figure. But that's something for the 21st century as compared to the 20th century. So the other thing that we do when we have this increased variability, enhanced variability, floods and droughts, the engineering solution that basically deals with that problem involves building dams. And so that's in this figure, which would be really, complex for the non-specialist. We project that you are going to have this much additional storage. So this is the storage in the Nile, the highest one dam. Now you have GERD. So with that, you have a return period of about 6 years. So if you want to keep that return period in the future with the red line, you need to expand your storage capacity by something close to the scale of GERD or even more, maybe something close to the highest one dam. So this is an early indication that in order to adapt to climate change, for the Nile Basin, there will be a need to add storage, an additional storage capacity that would help control variability between flood and drought years. So let me, I know that we in Sudan these days need to have some sort of good news, with all the bad news we have with, COVID and then floods and then the economy and so on. So let's try and extract some good news out of this. So I already talked about this flooding that happened here, the dumping of a lot of rainfall in the upper Blue Nile, and that's what caused the flooding. I mean, there were lots of misinformation in the social media about, cracks on the ground, geological things, GERD causing the flooding, highest one dam. That's all not true. The flooding has been caused by this event of extreme rainfall that happened in the last week of August, triggered by ocean conditions in the Pacific and the Indian that are conducive to flooding. So we fully understand what happened. There is no mystery about it. So that's what the main message of this lecture is, that we have good explanations for what happened. And that's shown here. This is the difference between what happened in 2020 versus the average of the last 20 years. And you see in blue is when you have wetter conditions than the last 20 years. And here I'm pointing to what caused the flooding. But in good news, I would like to point to all these green areas, green and blue areas, extending from the Red Sea, into central Sudan and going into Western Kordofan and northern Darfur. This is all areas that received more rainfall than what they receive. And these areas that need to receive rainfall. This is the dry region, the dry transition region from the desert into Sudan, and it all received significantly more rainfall. Another good news is you see here that the area around Gadarif did get average to above average rainfall, and that's the productive rain-fed agriculture that Sudan depends on. So that's good news that Gadarif and the area around it received significant rainfall this year. This area here, this blob, is actually, this is centered around Sinjar. And you heard in the news how all this, flooding and all kind of deaths and so on that occurred. This blob here of blue, this is around Sinjar and southern Sinnar, and that's what people experience. However, I would like to emphasize this belt here of green to blue that goes to in places like Al Fashir and Kutum and northern Darfur and around Al Ubayd and into eastern Sudan. That all receive more rainfall. What you see here in brown is actually less rainfall, but less rainfall happening in areas where you get plenty of rainfall usually, like southern Blue Nile region, South Kordofan and so on, and some of South Sudan. These are areas that receive a lot of rainfall, and so they don't have water shortages. So it's more important that the increases that are happening further north. So I see that as good news, the other side of the coin for this flooding. The last piece of good news with a question, this is a satellite actually estimate of the level of water in Lake Nasser. You don't get this data from Egypt easily, but you could get it from satellites. And you see here, this is actually only a few days ago, this point, the last point here, the level of water in Lake Nasser is pretty high. And so with this flooding that's happening, when it gets to Lake Nasser, almost the lake is going to be full. I'm certain that, the Egyptians would be now, the Minister of Irrigation in Egypt would be very busy trying to get water out of the reservoir and use it somewhere so that they could empty some space for filling the reservoir. The reservoir would definitely be full by very soon, in a few months. And that's good news when you put it in the context of all this GERD and depending on how Egypt uses that water. I think it offers an opportunity that it gives people a space that maybe some water could be allocated for the filling of GERD, and a negotiated agreement, legally binding agreement would be reached between Ethiopia and Sudan and Egypt to let this development on GERD go in a positive track. But that depends on how the countries use that. But clearly, the solid data is that the highest one dam is getting full very soon. So they have to, concern for them now would be how do they manage the flow coming in, because otherwise you get some spillage through spillways or to the Toshka Depression or somewhere. So that's all, and I would be happy to take any questions. I have acknowledgements for my group. Yunwo Choi actually did help with this analysis of the rainfall. Zarug and Siam did some of the previous work. Thank you very much, and I'm happy to answer questions.
نشكر بروفيسور فاتح على هذه المحاضرة القيمة. حقيقة ابتدينا نتلقى كمية من الأسئلة خلال الشات. What I'm gonna do هاخد الأسئلة في الشات أولاً، ثم بعد ذلك هنبدأ نفتح الفرصة للناس الرافعين يدينهم. Please use the raised hand facility in the Zoom so that people can ask questions. And رجاءً إنه زمن السؤال أن يكون دقيقة، ذلك لإعطاء أكبر فرصة للأخوان والأخوات للمشاركة والأسئلة. هناك عدة أسئلة. The first question is, how frequent do these factors that are observed to cause the flood meet? Someone is asking, is it every 20 years, for instance? This is mainly the combination of the Pacific Ocean as well as the South Indian Ocean, Prof.
Yeah, I think we could get a guess of that in one of the figures. It doesn't happen that often because, I mean, thanks God that it doesn't happen that often, because if it does, we would be like facing flooding conditions frequently. But to be more accurate, I think you could see it here in this figure, like, is basically the frequency. This is what happened in the past. Conditions where the Indian Ocean was cold and you get high flow. These are the years, and similarly for the Pacific Ocean. So it doesn't happen that often. Maybe once every maybe 20 years, once every it's not something that happens every year or every few years. It's more like at decadal time scales.
There is a couple of questions about the impact of GERD on Sudan, and I'm trying to lump some them in a couple of questions. And I think the biggest question is, what will be the impact of the opening of the spillways of the dam when we have a higher rainfall falling in the Ethiopian area. And people are really asking those questions to know what will be the impact in Sudan.
Yeah, I think that's something I addressed with this figure. I mean, it's good news. It's definitely good news. It's basically, it works on the seasonality. What GERD tries to do is to kill the seasonality. So after GERD is going to be flat. I mean, many of the audience may have been to Egypt. In Egypt, the Nile doesn't have that seasonality. You just like, if you go to Cairo, for example, it's the same location every time you go. It's very little changes. That's the kind of thing that similar to that would be expected in Sudan after GERD is operated. There is going to be some variation, because what GERD does to a large degree, it kills the seasonality, but you may have interannual variability. But the seasonality signal is very large, so that people would notice some changes, but there would be hopefully there would be no flooding. So it's a very in that regard is a very significant impact. It's not a minor thing. And then in addition to that, Sudan has Ruseris and Sinnar to operate, and so I think in that era, flood control is going to be to a large degree a minimal concern. And I came up with this figure so that people could visualize it. This is what the flow in Aswan used to be. It used to have these wild fluctuations, and now look at it. What's happening? It's just like, it's true that the highest one dam is larger. It's larger, and it does interannual variability too. But to a large degree, like you may see, in Gert, some fluctuations of this magnitude. It doesn't get up there. So if your experience is what happened before Gert, like the flooding that's happening now, you would notice that problem is to a large degree solved.
دكتور الفاتح، أنا هاخد أسئلة مباشرة. هفتح المجال الآن. الأخ الخناقي. Please unmute yourself and go please.
Okay, thank you very much. Totally, I disagree with the speaker, because the speaker is talking the theory, but I have some question because I'm not allowed to speak or to elaborate about his lecture. Speaking that from Benishangul people, where the great dumping dam is being built without our consent. We are the people now who are facing ethnic cleansing because of the dumping dam. And I think the next, as the Sudanese, we're going to see also the ethnic cleansing, not by bullet of the Ethiopian, by the water of the great. My question to the lecturer, do you saw the hazard and the safety study have been done to this dam? Did you see and observe the operating of this dumping dam after they fill the water since June? Do you know that the Ethiopians, they start filling this dam since June, not July, without informing the Sudanese or downstream countries like Sudan and Egypt? Do you know that also they start releasing the water after the rain, the heavy rain came to them, unexpected heavy rain came to them to save their dam, and they release the water, and that is the reason of the flood, not the climate change. Don't blame climate change to that. The reason of Sudan now, all of them is swimming in water because the Ethiopian filled the dam without consent starting from June, and then release the water. When the water, they're going to overcome the dam without also telling Sudanese. I'm saying this because that is my place. That is my grand, and me. I've been live and born since the time God created Adam today. I'm saying this because every minute I get a call from there. Why you are speaking now, I got a call from that place. Thank you.
هل ممكن نوقف السؤال هنا؟
Yeah, I think I could address this. I don't want this lecture to be about GERD. That's not the topic. It's a tangential topic to it, and I think I addressed the impacts of GERD on flooding. And for broader set of views about GERD, I have written a document that's available in the website for the Association of Sudanese American Professors, asapa.online. You go there to the bulletin board. There is a document that I wrote. It has significant discussion of GERD and all the issues related to it. And so for a constructive exchange, I would just suggest that people consult that.
السؤال الثاني أخ دكتور أحمد أبو اليمن.
شكرا أخي علي. السلام عليكم ورحمة الله تعالى وبركاته. بروفيسور الفاتح، جزاك الله خير على المحاضرة القيمة. This is very interesting, very enlightening. I learned a lot, and may Allah give you tawfiq. I will try to be as brief and quick as possible. I have just a comment and a question. It is really comforting to hear that GERD has something good in it. That's what my understanding was. But unfortunately, the politics, whether from Egypt or others, basically they frighten us, from the dam. And you mentioned that the GERD dam, there were some rumors about crack that happened on it, but that wasn't the case. I heard that the dam was built on an active area when it comes to earthquakes, and that might put some pressure on the area, which can lead to some shaking on the area. Not sure how true that is, but if that happened, then that would be a big crisis. My second question is that how much Sudan as a country is informed about with all this forecast that you have mentioned, because we know that there are many people in the Sudan today, because of the corrupt governments in the past, they have been approved to live in areas that are flood magnets. And that is very sad. But if we know, ahead of time, a week or a month, that this is going to happen because of the cooling that's happening on the ocean, can there be some displacement for those people? So that would be the number one priority. It may be too much to ask given the Sudan resources today, but it's just a thought. Because that's the only way to deal with this problem. وشكرا جزيلا وآسف على الإطالة.
Okay, so I think related to the issue of GERD, the document I referenced and I still reference, it basically advises to have a rational and pragmatic approach to it. There is no project that's all evil and no project that all benefits. So GERD has some positive impacts on Sudan. It has some negative impacts on Sudan. And I concluded that, the balance of the evidence is positive. And that is explained in the document. I did not say that there is any cracks. I said there are some people who suggest that the reason we have flooding is because of geological movement. There are some, plate tectonics going on, and that's why you got this flooding. And that's what I was referring to. Related to the issue of people being, living in floodplains and flooding areas, that's actually a very important area that the government could invest in. Is that there has to be empowerment of the civil defense organization. There is a civil defense authority in Sudan. They have to empower them so that they could really find those locations where there is a high vulnerability to flooding and maybe move the population from those areas. They have to be fair zoning of where those areas are, moving the people, providing them with housing in other locations, and making sure that those areas are not settled again. That preventive work is actually as important as any work to be done in forecasting or in any explanations like what I have been, because that preventive approach is what effectively reduces the risk. As all of us now, or most of the audience living in the US know, that there is zoning in all the areas, and there is flood zones. Like at least here we have it in the Northeast, and when you come to buy a property, where if it's in the flooding zone. So there has to be something similar there, and there has to be enforcement, and that potentially could reduce a lot of these risks. And I gave the specific example of Tamaniyat to illustrate that. So you either relocate people beforehand, or you have to basically wait for nature to take care of that. And that's what happened, unfortunately, to this population. And it wiped out the whole village. All the houses are destroyed, everything. And I hope that will not happen again to any village in Sudan.
بروف الفاتح، أنا هاخد سؤالين من الشات ويمكن يكونوا مرتبطات ببعض. أول سؤال، هل يمكن can we increase Rosaris Dam storage so that to improve our flood protection in Sudan, as well as there is another question kind of related. Can we drain this water that's coming to underground storage so that we can improve areas far away from the Nile?
You know, the Rosaris Dam, you know, what I described, I mean, a dam is being built ahead of a Rosaris. So the function of a Rosaris Dam in flood protection, if GERD goes ahead, then that's, you know, is going to be obsolete in a sense that someone is doing that ahead of you anyway. So you are not going to need that service. What I have been advocating, however, and I have a piece actually already written in which I will make some details about that. I'm an advocate for expanding the generating capacity of Rosaris. You know, the existing generating capacity could be increased significantly at a limited cost. So that's what changes could be introduced to Rosaris. As far as storing water in the groundwater, that's actually is not fast enough. You know, if you think about it, what happened, this flooding, it took like days. It happened in days, a week, maybe 10 days. That's, you know, flow of water into the groundwater is a slow process by its nature. And so I think that's not a viable option. One option that people do in some areas is you generate, you know, retention ponds in some locations next to villages and so on, so that you could divert some of the water into them. You could also build some of these dams that they built on wadis to retain water before it gets to human populations. So there are approaches where you could do surface storage, but the groundwater, unfortunately, is a slow process that does not help you with flooding, because flooding by its nature is a fast process, and you need to have the ability to act in short time scales.
هفتح السؤال دلوقتي للمشاركين. الأخ ضياء النعيم. الأخ ضياء.
أول دكتور عبد الرحمن لو سمحت.
دكتور عبد الرحمن إذن.
السلام عليكم. شكرا أخ علي على الفرصة. And thank you, Professor Fatih, for an excellent presentation, and it's very informative. And I agree completely about the human factor, the social part in that presentation, and how that would be good as far as even starting to use the good news so that people can benefit even from this. My question is about the natural part of it and the sudden change which happened at the end of May. Is that what causes it, and is it controllable or can be predicted ahead of time? Because it looks like it happened suddenly, and I don't know what the influence of the human behavior and things we're doing on Earth will affect that, but can be predicted ahead of time, like Al-Akh Ahmed, Dr. Ahmed, Sheikh Ahmed Gali knew that we could be prepared already for it? How, because it looks like it is happening. What causes it to happen suddenly?
Yeah, I think, thank you for the question. I think this is what you are referring to, is the fact that the temperature of the Pacific Ocean just, you know, in a very short period of about 1 month went from being warm to being cold. And that part of this, you know, video that I showed, the El Niño phenomenon, this is the dynamics, the coupled ocean atmosphere dynamics. And it's predictable. It's predictable up to like 6 months. And that's why I basically propose this methodology that I showed earlier. Like if we have a prediction about the sea surface temperature evolution, and this is one of the models, this is the European model, the European Center for Medium Range Weather Forecast, trying to predict the SST. So the different lines is like different runs by the model, and you take the average of them, and the dotted is what has been observed. So you see the average of these projections by the model, they fit what has happened. So the phenomenon is predictable. And what I advocate is that we could do better job in Sudan in taking those predictions and translating them into information about flooding. Okay, and that's something that for a while, our colleague, Dr. Yusuf Ibrahim, when he was at the ENTRO office in Addis Ababa, he actually did that. He utilized this methodology to try and come up with projection that the region, countries in the region could use it.
Sorry, but you knew about it 6 months ago?
This phenomenon, you could know about it 6 months, but not every year.
Specifically talking about this one.
This one, I think you actually, when I went back to the record, I think you could project what happened in August and September starting in June. In June, there were indications, in early June, there were indications that the ocean is moving into that direction. Okay, you know, nature is complex. I mean, people, I have to remind people that we are talking about natural variability, and this is a variability that in the past we were totally ignorant about. In the past, if you asked about what's going to happen in 6 months, what's going to happen in the flood of the Nile in 3 months, nobody knows. You just have to wait for it. The weather forecast, as all of you know, it has a theoretical limit of about 10 days to 14 days. And usually I don't trust them for more than a few days. So I could really hardly trust in 5-6 days. So here we are talking about projecting conditions months ahead of time. And that's not an easy task, you know? And it's, what we are utilizing is that the ocean has a slow time scale. And so you could project the conditions of the ocean at longer time. In this specific case, after the flooding happened, because I wasn't following this closely, I was busy with other types of research I do. When this flooding happened, and I went and I looked at what these prediction centers are doing, for example, the ECMWF, the one that I'm showing the picture for, I think as early as June, they had indication that the ocean is heading in that direction. And that's, you know, and that's, so that's the kind of information that I hope in the future, you know, we would extract that information and we would give us long-term planning horizon that we could prepare for events like this. So that's on the side of forecasting, seasonal forecasting. And then on the side of vulnerability, it's easier to basically define flood zones and areas that are not safe for human settlements, and make sure that the populations are not you know, given permissions to reside there, because that basically endangers their safety when you have big floods.
So I'm really sorry for everyone that I didn't know how the order I received the hand raising. So I will go with what's in front of me here.
السلام، أنا كنت جاهز للإجابة. معك ضياء الدين النعيم.
أيوة ضياء.
أيوة. السلام ورحمة الله. أنا لحسن الحظ أنه عبد الرحمن وفر لي، الأخ عبد الرحمن وفر لي جزء من الزمن، وهو سأل السؤال أنا عايز أعيده في صياغة أخرى، اللي هو موضوع الإيرلي وورنينج. بروفيسور الفاتح، قبل كل شيء شكري جزيل على الندوة القيمة دي اللي هي أنا ممكن أسميها محاضرة العام. ويجب أنه يعني الجهة المنظمة تسعى للحصول على إذن للتسجيل ونشر التسجيل في تلفزيون السودان عدة مرات. الموضوع ده أنا بالنسبة لي هو مش الإشكالية الكبيرة بتاعتنا نحن كشعب سوداني والنخبة السودانية وإدمان الفشل. الايرلي وورنينج هسه هذه بروفيسور الفاتح قال انه هو متوقع او على الحد الادنى كان في قبل شهر وشهرين وطلع في CNN انه الانسو الانديكيشنز ماشيه في النينيا از كامينج، واتعرف يعني باي اوغست وكده. بروفيسور الفاتح forefront scientist وبيزي في ساينس وهيز بروديوسينج الساينس. الاشكاليه هي في احترام العلم. يعني زي ما هسه الاخ الخناقي حاول يقول كل الكلام ده ما صحيح بس كده لانه هو التلفونات جاته. العلم هديه والايرلي وورنينج موجود والخبره موجوده. وين الناس اللي حيتصلوا بالساينتست دي ويسالوه عن البريدكشن فور ذيس يير شنو؟ لانه لو كان في ايرلي وورنينج بتاع 3 يوم فقط انه الديزاستر دي is going to be to that scale، كانوا الناس على الاقل عملوا التروس بتاعتهم دي وما احتاجوا يمشوا جوا المويه وعملوا تروسهم. لكن الناس بعد ما المويه غتستهم حتى بدوا وماتوا ناس. فيجب انه الموضوع ده يؤخذ بصوره جاده وما يتكرر على الاطلاق ثاني، انه لابد يحصل الربط بين الساينتست اللي بيعملوا البريدكشن دي والميديا والديسيجن ميكرز، وانه المواطن المسكين تكون عنده المعلومه. وده
اخ ضياء انت فوت الدقيقه بتاعتك. شكرا جزيلا لك يا اخي، لانه عشان ندي فرصه للاخوان ثاني. شكرا.
يا لو سمحت دكتور علي. So I think I would like to say that there is room for prediction of likely conditions in the future. يعني every year there is room for that. This work has been published for some time, and I think there is room for improvement. For in the Ministry of Water Resources, there is room for improvement, and I think the al-Akhwan Hinak, they realize that in the technology that's being used to make projections into the future. However, I have to say too that this is not, you know, in many ways, this is not an exact science, because if you think about it, when we see there is called SST, we do not tell exactly that you are going to have a high flow. We say, yeah, the probability that you are going to have an average flow is like 50%, high flow is 50%, you are not going to have a low flow. And that's what makes, you know, transmission of this information to the public is very challenging. And taking action on it is very challenging. So it's not like, you know, we knew exactly ahead of time that this flooding is going to happen. But we have indication that things are moving in that direction. And those indications, they come in probabilistic terms. So I am very much for using that information to be able to prepare yourself for the likelihood that you may have a flood, or you may likelihood actually, when you have El Nino, you are likely to have, you know, droughts or low flow. And so that information, I think, can be used and can be used better. However, I don't want also to be lean too hard on our colleagues in the Ministry of Water Resources, that it's not like we had perfect projections and they did not follow it. The reality is a little bit more complex. And that has to do with the fact that the problem we are trying to address is a difficult problem, you know? Is a difficult problem. I have been involved with an issue like this in another part of the world, in Morocco, where I have a research project, and we came up with projections about precipitation in Morocco, and we came to, you know, with those projections 1 month ahead of time. When we talked to some of the people who could use it, some of them in the industry there, they had farms and so on. They said, "Oh, actually, we would like to have this 6 months ahead of time. Would, you know, how we would impact our operation if I know 6 months ahead of time this is going to be the rainy season." But that information is not there, and it's not easily obtainable. And so the challenge is being able to use whatever information is available and utilize it in an effective way to help improve better management of the water resources.
الأخوان السائلين أرجو أن تلتزموا بمدة الدقيقة للسؤال. Please get to the point عشان نقدر ناخذ أكبر عدد من الأسئلة. أنا لسه عندي عدد من الأخوان رافعين يدهم، I will go to عثمان البخيت.
السلام عليكم. عندي سؤالين في نفس الموضوع. أولا التحذير الشعبي، يعني أنتم دوركم كعلماء دكتور الفاتح في المستقبل. نحن ما بنثق في الحكومات ولا في الإدارة العامة في السودان وكذا. لو في المستقبل أنتم كعلماء اتجمعتوا وعرفتوا المعلومات دي ahead of time وأرسلتوا إنذار مبكر للناس، حتى الناس الساكنين على ضفاف النيل يجهزوا نفسهم لحالهم، يجهزوا الأكياس والشوالات والرملة ويجهزوا نفسهم للتروس. هل بتفكروا في عملية بالشكل ده
تقوموا حاجة مستقبلية، تحذير مبكر للناس مش للحكومة. شكرا.
Yeah, I think the answer goes back to my previous answer. You know, communicating this kind of information directly to the public is not feasible. You know, for example, the table I have in front of me here, it says that, yeah, if I have cold SST, then there is a 50% chance I'm going to have an average flow, 50% chance I'm going to have a high flow. I am ruling out having droughts, but I don't know exactly if it's going to be an average or a high flow. And that has to do with the fact that in the past, you look here at all these years, when the sea surface temperature was cold, some of the years were even low, but more likely is high flow. More likely is high flow. There is a probabilistic aspect to it. So this information is best fed to the agencies that does interact with the public. And those agencies have to develop ways to use the information in an optimal way. On one hand, you don't want to like overkill the information in the sense of like take too much action. So this information is not actionable in the sense that you would go and say, okay, you should go and buy shuwalat and start preparing yourself because there is a flood coming. But on the other hand, if you look at the last 30 or 40 years, whenever the SST was cold in the ocean, you had, you know, more likelihood that you are going to have a flood, and vice versa when you have a warm SST. So that probabilistic nature of the projection, the uncertainty, dealing with that uncertainty is a complex process, okay? And transmitting that uncertainty to the public is better done through specialized agencies that are dedicated to the water resources management. And so there has to be an intermediate step between the science, you know, creation of knowledge, putting the knowledge in a way that people could access it, and then someone who take that and tailor that information to help the operational side of their management.
الأخ مهند.
Assalamu alaikum.
عليكم السلام.
Can you hear me?
Yes.
Bro Fatih, thank you so much for the informative presentation. My question is, for the Blue Nile, okay, the rainfall maybe was the first reason for the floods in the Blue Nile, but what about the White Nile, especially that the White Nile rainfalls and the floods could be dissipated in the South Sudan, في منطقة البحيرات.
Yeah,
but
that's
still,
yeah, that's a good question, Mohammed.
We had the flood in the White Nile along the Kalakla and so on. So what could be the reason for that? My second question is, I got a copy of the IPOA report, International Panel of Experts, about the GERD design. It was published in 2014. I'm asking if there are any updated studies available for the public, either it was published by IPOA or any other organization, so that the public can have a review for it. My last question is about the GERD, the early filling of GERD in June, July. Do you think it could be a potential reason for the floods, the current floods in Sudan? يعني هم الجماعة دي بدوا يملوا في جون جولاي، خلصوا البلن الأولي ملوا ال 4 مليار متر مكعب دقيقة. بعد كده يعني هل تفتكر لو كان أخر الملي بتاعهم ده مثلا في أغسطس أو في الفترة بتاعت الأمطار الغزيرة دي، هل كان الحاجة دي ممكن تمنع الفيضانات حاليا في السودان؟ Thank you so much.
Yeah, this is all important questions, and I think the first question actually is a very good one about the White Nile, and that's, you know, look at this chart here. So the White Nile, when the Blue Nile increases rapidly during the time scale of like July, August, you see that the White Nile, you know, it flattens and it's either goes down, and that because the Blue Nile acts like a dam for the White Nile. Think about it. I don't know if you have been at all crossing a White Nile bridge, Khartoum, Kubrini, Al-Abyad, you know, where you see the Blue Nile coming to, the White Nile coming to really meet the Blue Nile from Mugren. You know, when the Blue Nile rises rapidly, that rise in the Blue Nile, the rapid rise, it becomes like acts like in a way like a dam for the White Nile. And so the White Nile basically starts going up. the level of water in the White Nile starts going up. So that's part of why the White Nile gets impacted. It's impacted by a backwater effect. We call it a backwater effect coming from the from Al-Mugran. And you see it here very nicely. This is a figure that I did not produce this figure. This is a classical figure for the Nile. But you see it here how the Blue Nile really, like, the White Nile flow, when the Blue Nile goes up, the White Nile flow feels the fact that, this high rise of the Blue Nile. So that's I think is part of why you see the flooding in Kalaklat and all those areas. In addition to the fact that, as I showed earlier, there is a lot of settlements very close to the river that has expanded in the last 30 years. I am not sure about this IPO report you talk about. As I said earlier, I have written a document about my views on GERD, and it's available in this asapa.online in the bulletin board. And that's all what I would like to say about GERD. It has I summarized all the views about it, and I'm not sure if there is another report coming up on it.
And Bro, I think someone referenced it in the chat, so you can reference your paper on the chat. So if someone is interested, they can go to the chat and find it.
Yeah, that's actually, I think I answer all the questions. I put there all what I know about GERD, so that if someone is really interested in that, they could read it.
Thank you so much, Professor.
Yeah, the last thing, Mohammed, is you asked the question about the filling. The filling, the fact that they filled, it actually took some water out of the system. So that's in a way could not cause flooding. If you think about it, a lot of the theories that people advance to really how the flooding happened, they don't make sense even in the basic terms. Like one suggestion is there is a crack, geological crack, because of the movement of the plates and so on. If you have a crack, that water would disappear in that crack. It would not come out, So that doesn't make sense. And then now, if Ethiopia took some water from the Nile, that would work to reduce the water. It's true that if they did the filling later, that may have helped by a small amount. But Ethiopia is not doing the filling or not doing it to help flood control in Sudan. In hindsight, yes, it would have been actually smarter to do that. In hindsight, given that we have this flooding situation. But when they did that, I don't think they knew that this is going to happen. But now, knowing what happened, if they really abstracted the water later than earlier, that may have helped a little bit, because the water that they stored is not much.
بروف الفاتح احنا عندنا حوالي we are over time that we talked about, and we have about 10 questions, so I just want to make sure that you are okay to take more questions from the audience.
Yeah, I think maybe we could take half of them and that's
sure. Ayman Hayasafi, please.
السلام عليكم بروف، شكرا جزيلا على الفيري انفورماتيف محاضرة دي ومعلومات قيمة جدا حقيقة. عندي أنا من منطقة الشنبات وشنبات يعني من أقدم المناطق في الخرطوم. الكونسيرن we hear from our people from شنبات إنه بيقولوا السنة دي يعني هم متعودين على الدميرة وما حصل هددت المناطق السكنية في شنبات. السؤال الأول بيقولوا ليه هم الموية بتاعتهم بيجين زي الموية النيل الأبيض، موية بيضاء. it's not موية بتاعت الدميرة، it's not flooding water. يعني موية هناك عندهم كلها شايفينها it's not like from Blue Nile water or something like it's just زي موية النيل الأبيض. ده تساؤل لهم. والحاجة الثانية أنا كمن شنبات يعني ما أنا متأكد I'm very sure like أنا ممكن إنه مشكلة بتاعتنا الرئيسية إنه من الحكومات السابقة اللي هي بند على شارع النيل، المنطقة تعدي علي النيل اللي هو المنطقة كلها بتاعتها. دي أثرت علينا في شنبات تأثير شديد، لأنه شنبات متعودين على الفيضان ده. دي نقطتين. Last question is about GERD. يعني I'm sorry إنه أنا عارف انا عندي concern لانه عندك interest في environment. The concern I have is about the turbines they're going to put into dirt. Is they going to put like ده كان كتبها البروف احمد عبد الرحمن عاقب عليه رحمه الله، بيقول انه الكونسير بتاعه انه التيرباين الافشنسي الجديده دي الافشنسي بتاعتها like 95% والحاجه زي دي، هم خاتينها في اسفل الهضبه الاثيوبيه. يعني معظم البوتنشال انرجي دي حتتحول لطاقه كهربائيه. So he like في كونسيرن انه دي تاثيرها على شنو ل 100 سنه لقدام في النيل. يعني هل حتزيد الضحاله بتاعت النيل لانها ديد ووترز؟ صحيح ما حتاثر على كميه المويه ولا اي شيء، لكن هي تكون ديد ووترز لانك انت شلت بوتنشال انرجي بتاعت 1300 متر مبي. فشكرا لك جزيلا على المحاضره القيمه، وشكرا لك يا دكتور علي على الفرصه.
Yeah, I think the first question about السالينيتي مش السالينيتي السيلت في الwater of the Nile next to Shambat. I know the area of Shambat very well too. I'm not sure why it would have water like the White Nile. I would have thought that it would have more. يعني لأنها is on the eastern side of the Nile.
Yeah.
This is the side that's closer to the Blue Nile. It would have more of the Blue Nile water, but I don't know exactly. There is a lot of complex sediment transport mechanisms that could explain that. And also we need to, someone has to collect data and verify that this is true, that, because it may be just anecdotal observation. So it's an interesting observation that maybe needs explanation. I don't know the explanation for it. The second question is about, it's everywhere around Khartoum that they have been, buildings on the side of the Nile on both sides, without really respecting the geomorphology of the river. In some parts of the US and Europe, people are moving the other way around. Construction that were made around on the side of rivers, people now are dismantling them to make the river act naturally. So it is a problem. It's very acute in this case of flooding. Hopefully, with the regulation that would come with GERD, it may be less of a problem in the future, because in the future you expect the river would be in a way controlled. And then the last question is about, if you remind me again, your third question.
Yeah, that's I said Prof. Ahmed Abdurrahman can.
Yeah, the question about the turbines.
Yeah,
that's an interesting concept. But if you think about it, a lot of the potential energy that comes through the turbines, it came from the fact that you constructed the dam itself. So a lot of the head that you generate the electricity from, the head at GERD or at the highest one dam, it comes as a result of building the dam. So that point where you have the turbines, not all the potential energy there is a natural potential energy. So I wonder if that process is a significant one, but it could be. But I'm not. My gut feeling now that it is not a significant process.
Yeah, because they put the turbine under الهضبة أسفل الهضبة. يعني whatever construction you have in the upper level of the هضبة, it's not gonna be like, it's not gonna affect, because the turbine gonna take the 95%.
Yeah, I think it's the potential energy that's associated with that water.
Yeah.
A significant part of it is artificial. It's created by the fact that you build the dam. Without the existence of the dam, the drop in head is significantly smaller than the drop in head that you have after you build the dam.
Thank you.
شكرا جزيلا يا أخ أيمن. أخذ السؤال الثاني يا جماعة، للأسف يعني أنا I have to go quickly here. مهدي، شيخ مهدي.
السلام عليكم.
وعليكم السلام ورحمة الله وبركاته.
Actually, I don't have a question. It's just a remark. The professor mentioned some dates when he said 1880 equal to 1306 Hijri. But I don't think that's right. I guess
1888, Mahdi. It's not 1888.
1888. Okay, thank you.
I said in the 1880s, Sudan can conditions that, so the socio-economic conditions in the 1880s, but the exact year for El Nino, which is actually a remarkable fact. If you think about it, it's a remarkable fact that the year of مجاعة سنة 6 في السودان was an El Nino year. So the reason that you had مجاعة سنة 6 في السودان is to a large degree is due to the El Nino year, because you had, you know, the Pacific Ocean was warm in that year. That's recorded independently. And we know when the Pacific Ocean is warm, you have less rainfall and you have less river flow. And that corresponded with the year 1306, which is مجاعة سنة 6. And my point is that 1914, on the other hand, was actually lower. The lowest year of flow of the Nile was 1914, which was an El Nino year too, which is also a remarkable fact. In 1914, the lowest year, the lowest flow in the Nile in 1914 was associated with an El Nino. In that year too, the Pacific Ocean was very warm. Okay. However, in 1914, there was no Majaa. You know, it was just a normal year. There is nothing in the history written about it. So the 1888, however, there was a big event. It was, you know, we heard, I mean, I heard it from oral history. You know, I grew up in Sudan, and I heard that from oral history from people. Like, you know, it's like it's a madrab lil-mathal when you talk about very severe conditions. And it seems to be like a combination of the natural hazard associated with El Nino and the vulnerability associated with the socioeconomic conditions in Sudan. And when I read in the history, that the same year is the year in which the army of Al-Khalifa Abdullah actually had a mission into Ethiopia, and they had a big fight over there, and there was mobilization of the people in Sudan. And I think in a way that people, instead of taking care of agriculture and taking care of feeding themselves, they were busy in the fight. And while they were busy in the fight, they had a very dry year. The rainfall was not enough, and the flow of the river was not enough. Another result, you know, that combination resulted in the unfortunate occurrence of that Majaa. This is the only Majaa that we know really in our recent history in Sudan. I mean, we had shortages and problems in the 1980s, but they did not. You know, we had help from the international world, and so, but that time in 1888, that wasn't available, and so I guess many people died and many people suffered. So I think it's an interesting case of convergence of a natural hazard that we understand how it came about with a socioeconomic vulnerability that has been documented in the history of Sudan.
ناخذ آخر سؤالين. الأخ عمار.
Hello.
تفضل يا أخ عمار.
Thank you, Professor, and your followers. My question is simple. What I know this year, the rainfall is high comparing with the other years. The question is, the normal people, there are some of them blaming Egypt, and others, they say because of Ethiopian dam. But really, I want to know, the reason is done by the human or just naturally flood? I think this prediction is good, and then the government should take responsibilities like this prediction. But the normal people didn't know, so we need to do more prediction like as Professor done. This is my question.
Okay, thank you, Ammar. I think to answer your question, it's a natural, what happened is a natural phenomenon. I don't think it has anything to do with highest one dam or has to do with GERD, or that's not, if we didn't have GERD at all, it was not in the picture at all, we would have faced the same situation. And I think we understand that. I showed, the condition in the global oceans, and I showed also the satellites did detect this extreme rainfall that happened in the last week of August. And I think a key issue is the timing, the fact that, that in this picture here, you had an anomalous rainfall happening at the worst time you could get it. Usually, I mean, if you get it in June, anomalous rainfall, or July or some, it would be like, impacting this curve in some place where the flow is not very high. But during the time scale of last week of August, last half of August, the first week of September, this is a time that usually the Nile level is very high. And if under those conditions, you get an anomalous rainfall event in the catchment, then that rainfall has the potential to result in a lot of flooding. And I think that's what happened. So it's a natural occurrence. And I think the issue about, forecasting and predictions, I addressed that earlier.
السؤال الأخير هشام الخضر. الفرصة لهشام الخضر سؤال.
I have a question, please. Hello?
هشام الخضر.
I am Iba Imad. I have a question. Can I?
Go ahead.
Yes, thank you very much for the informative lectures, Dr. Fatih. You talk in the future about how to control the flood in Sudan by constructing dams. Where do you think the suitable location of it?
Yeah, that's a good question. I did not say Sudan should construct dams. I said there has to be additional storage. I did not say where. It's not a trivial question where you would do that. There have been sites in Sudan that have been basically studied for dams in the past. Those could be studied again or considered again. There are sites in Ethiopia too. But my point is that if we want to manage the fact that you are going to have more extreme floods like the one I'm showing here, that means the storage capacity that you have will not be enough. And so you need to add storage. The engineering solution, whenever engineers has to deal with variability, a standard solution is you build storage capacity so that you could store the water. This is especially that we live in a region, the Nile Basin.
Okay, أفتكر هشام he was unable to unmute. So.
There is too little water and too many people in the Nile, and so that's because of that we need to build more storage. But I think we are trying to now just like explore even the concept of that. Convince people that there would be more need for storage capacity. Where would we put them? I hope by the time we get to do that, there is more agreement between these three countries, Sudan, Egypt, and Ethiopia, on water issues, and then engineers could decide to locate these dams in the most optimal location for the benefit of all.
Assalamu alaikum. I have just managed to unmute myself. مساء الخير عليكم وصباح الخير على those who are in other parts of the world. Professor Fatih, thank you very much for a very stimulating and informative talk. And my hat goes off to you. You are really a leader in this field. My question, you alluded to two conducive factors regarding when they come together, the Pacific cooling effect and the South Indian cooling effect, as well as the rain fall that can be predictive to the flooding that occurs in the Nile. The question is, do these factors also affect the Adbara and the Sobat, which provide about 1 unit, as you started off with your lecture? And and these factors, well, and how much does the Adbar and Sobat, if they do gain that much water, how much do they provide as part of the flooding that may affect Sudan? A very quick second question, Yani, please excuse my ignorance. Will the body of water that's created by the Gerd Reservoir have any effect on the climate and may affect these factors that you have spoken about? Thank you very much for your time, and I look forward to your answers.
Okay, thank you for very good questions, actually. Let me show you, you asked the question about Sobat and Adbara. Yes, Sobat and Adbara, both of them gets impacted by these factors. You know, both of them, all the rainfall over the Ethiopian plateau and even the rainfall over Sudan, and over the Ethiopian plateau, they all correlate to these factors, especially the Pacific Ocean. And so, yes, Adbara and Sobat will be impacted. Sobat, however, you know, because the water from Sobat goes through this mashar swamps in South Sudan, that provide like a buffer, so that, you know, it buffers the flow into the White Nile a little bit, because it goes into these swamps and just that delays and mutes the flooding that comes out of it, but eventually it comes into the Nile. The Adbara River, on the other hand, is a different story. The Adbara could really have big flooding. You notice here in this year that this map, the Adbara River catchment, which is this area I'm pointing to, has actually received less than the average rainfall that you may get every year. And so in a way that did not play. I mean, I don't expect, I haven't seen records for Adbara, but I expect that Adbara did not really see much flooding because of this decline in rainfall. I would be surprised if otherwise. This is what the Blue Nile source, and that's where you see the excess rain. And then you ask the question about, would the existence of GERD, the water body, would that have impact on the climate? It has impact on what we call the microclimate. The microclimate is like if you are a village just next to the reservoir, you know, Roseris or like Gerd or like the Marawi or the highest one dam, a village or a small town next to it, when the air blows from the dam, from the reservoir towards the village, it gets to be cooler and more humid. That's what we call the microclimate. So these small water bodies, they impact the microclimate. The regional climate, which really what shapes the distribution and the occurrence of precipitation, rainfall, that does not get impacted when you have water bodies that are that small. You need water bodies that have the scale of about hundreds to thousands of kilometers. So that takes you to like scale of the Black Sea or the scale of, you know, a large water body where because of the extensive scale, you may start impacting the circulation in the atmosphere and the rainfall occurrence. However, reservoirs that are of the scale of Lake Tana or like Gerd or Roseris or Marawi or even the highest one dam, they are not expected to have a significant impact on the rainfall in the surrounding areas, although they may have impact on the microclimate described by things like temperature and humidity in the surrounding area.
يعني حقيقة كان بودي إنه آخذ كل الأسئلة، لكن الزمن حقيقة إحنا كنا المفروض ننتهي 1:30 ودلوقتي الساعة 2:05، فعذرا بروف الفاتح إنه أخذنا الزمن، وعذرا لكل الناس إنه أخذنا زمن زيادة عن زمن المحاضرة، لكن الموضوع شيق والموضوع طويل ولسه في أسئلة جات عن طريق الشات. إن شاء الله I will share it with you يا بروف. And if people want, I will try to get back some answers and we'll share it with الجالية. حقيقة في النهاية يعني في الختام هذه الندوة اليوم أحب أشكر بروف الفاتح على هذه المحاضرة القيمة، ونسأل الله سبحانه وتعالى أن ينفعنا بعلمه وينفع السودان بعلمه وينفع السودان بعلم جميع الناس، وحقيقة ويرفع البلاء عن أهلنا في السودان في هذه الظروف الصعبة التي يمرون بها. كما أود أن أشكر جميع الحضور ومشاركتهم الفعالة. حقيقة الأسئلة كانت مفيدة وأثرت النقاش، وحقيقة أنا عارف إنه كمية من الناس عندها أسئلة زيادة عن الموضوع ده، وموضوع يعني مواضيع كثيرة مترابطة، وزي ما قال بروفيسور الفاتح يعني علم الموية ده ما it's a very complex issue يعني it's related to so many other things, and I can attest to that. It's a very difficult to make decisions based on predictions and things like that. Even we see it here in the United States when we are doing actual management of floodplains as well as resources. في النهاية الشكر للجالية والشكر للأخت سناء مرسي والأخ محمد يوسف على مساهمتهم في تفعيل هذه الندوة والمساعدة providing all the logistic support that we have here today. برضو بشكر الأخ وليد البشير اللي هو حاول بقدر الإمكان إنه to provide some translation during the process, the prof lecture, and I really appreciate that also. في الختام الشكر للجالية، ولا تنسوا دعم الأهل بالسودان عن طريق اللينكس share that was shared in the chat and shared through this process. في الختام الشكر الجزيل لبروف الفاتح، الشكر الجزيل لكم كلكم، وإن شاء الله يعني نختم على كده، والسلام عليكم ورحمة الله تعالى وبركاته.
شكرا جزيلا.
تمام، وشكرا جزيلا، شكرا لمالك دكتور علي على الدعم الممتاز جدا لانه زي ده وزي ذكرتها. شكرا للدور كلهم، للبروف معلومات الغنية جدا. وندعو أهلنا كمان نذكر كلهم بالطبعات، ندعو لهم ربنا يرفع البلاء، وبما فيهم أنا في بنقول المتأسف بالخزان بيصدرناها. نتمنى برضو إنه يعني يكونوا في الله، ربنا يخفف لهم الضرر وكذا. وشكرا للجميع، وتابعوا معنا في الجروب تاعنا حلقات الأسبوع الجاي اللي ما نزلناه إن شاء الله تنزل من 3 جديد. شكرا جزيلا للجميع. معكم خالد العظيم من العائلة السودانية ولاية مينيسوتا. السلام عليكم.
السلام عليكم.